All right, ladies and gentlemen, we're going to learn about the introduction to hypothesis testing. In this video, we're going to cover the null and alternative hypotheses, type 1 and type 2 error, and also take a look at the distributions we can use in hypothesis testing. So, if we think back to the last unit, we had a lot of work with confidence intervals. And what was the purpose of confidence intervals? Well, the purpose of confidence intervals was to estimate this mu. We were to estimate mu, which is the average for a population. Now, where did we get this estimate of mu from? Well, we got it from a sample average, and we call that sample average x bar. So that sample average x bar, we then calculated a give and take, also known as the EBM, off of that x bar to give us an interval that we were either 90, 95, or 99% confident that our mu would be in between the low and the high number. Now, let's assume that we are happy with our average for the population, but since we created it using a confidence interval, we should probably test it, because that's the purpose of data and science, is to say, okay, we found this information, well, now let's make sure we can repeat this information so it's testable and valid. So this testing of an average mu is called hypothesis testing. And that's what we're going to be doing in this unit. We're going to be hypothesis testing. We're going to be taking a known mu, and we're going to make a claim or a test with it and see if the mu is to be either rejected or not rejected at this moment. Now, let's imagine we have a mu. So we have some kind of mu. What would cause us to doubt its validity? Well, what would happen is, let's say we find an average from another sample that's way different. Okay? So let's say, for example, that you think the average age of something is 24, and you start sampling a subgroup of your population, and you're finding out that that average of that subgroup isn't actually 24. It's way different. Now, the thing about hypothesis testing is that we have to use statistics to determine what is actually way different. Is it just slightly different, but not statistically significant? Or is it way different enough for us to basically question the reality of the average in the first place? And this would be something like, hey, we think that the average IQ is this, or we think the average test score is this. And then what you do is you take a little sample and figure out if that sample is way different than your actual average. Then you might have to question reality there. We can also do the same thing for percentages, and we're going to show you that later on in these videos, how to test percentages in the binomial sense. So what are the parts of a hypothesis test? Now, we're going to be doing most of these parts, because the first part of a hypothesis test, officially, is to set up contrary hypotheses. Okay, set up contrary hypotheses. And you do this because you have somebody who's saying, well, I think the average is this, and then the contrary hypothesis is to say, well, I think it's this instead. So we're going to be setting up contrary hypotheses, and before the end of this video, I'll give you examples of these hypotheses. Now, the step 2 is to collect the data, and you'll notice that I don't have a star by this one, and the reason why I don't is because the collection of data is something that the book will already do for you. In more rigorous courses, you'll actually do some of this, but this, to give you the idea of how the mathematics works, this is going to be the given information, usually in the form of averages, sample sizes, raw data, standard deviations, and so on and so forth. Now, step 3, something we're going to do is to determine the correct distribution and type of test. And we are going to only focus on 3 of these at the beginning, and we'll expand our portfolio of types of tests and distribution as we move on in this book. But we'll start off with just a simple choice between 3 different types of tests and or distributions. Now, step 4 is to analyze the calculations. Now, in this course, we're going to analyze the calculations using technology, and that's going to allow us to allow you to reject or not reject the null hypothesis. So this is the second time in this screen that you've seen here that we've mentioned hypotheses. Don't worry, we're very soon going to tell you what the null hypothesis is and what it stands for. But something about this sentence may have raised an eyebrow. You'll notice that I was careful about my wording where I said, we're going to analyze calculations to allow you to reject or not reject the null hypothesis. So you'll notice that we didn't use the word except, because except is the, kind of a logical opposite of reject, but this word except is not a word that we use in statistics. And the reason why we don't accept anything is because we're never going to be 100% sure of anything in the first place. Our confidence intervals were not 100% sure. And therefore, when we do a hypothesis test, we're either going to reject the null hypothesis and say, well, that's wrong, or we're going to say, well, we're not going to reject the null hypothesis, which means we haven't proven it wrong yet. What we hope is that our null hypothesis will never be rejected because it is a good average and represents the data robustly. As we do more and more statistics on it, it stays the same. But never say except. Only say we reject or do not reject or decline to reject the null hypothesis. And again, the reason why we do not accept is because we are never 100% sure. Never going to take that 100% option. We're going to give ourselves a statistical out. Now, what we just did is we helped to do number 5, which is make a conclusion. So we're going to make conclusions. We're going to make conclusions. All right, so those starred processes are going to be part of our hypothesis tests, which is going to be in the next series of videos. But this series of videos is going to kind of walk you up to starting to do a hypothesis test. And what we need to do is teach you what a null and an alternative hypothesis is. Okay, so the null is a way of saying, and I put this in quotes because this is kind of a way of saying this is the given. The null is the given. This is kind of what we are testing against or claiming against. And our alternative is going to be our test or the claim. So we're kind of working against this null hypothesis, and the null hypothesis would be H with a little 0 in the corner. And the alternative would be H with a little a in the corner. And some books and some courses teach this with H and a 0 and a H and a 1. 1, I guess, binarily being the opposite of 0, but I want to now use H sub 0 and H sub a for the null and the alternative. Now, the null hypothesis is basically saying that there is no difference between the sample average and mu. Now, I'm using these shortcuts. You can actually look on page 506 of the book and see the more robust definition. But what this is really saying is, look, we know that the average, let's go back to a previous example here, we know that the average age is 24 of this group and population. If we keep getting small samples, this x bar is going to be the same as mu, so there's just no reason to doubt our mu of 24. Okay, now I do want to highlight that I'm using this average here, and we do have percentages. We can actually, test the hypothesis that maybe 45% agree on an issue, and the null hypothesis would say, yeah, 45% is right. If you keep sampling this issue over and over and over again, you're going to get a 45% agreement. So that's another major reason why the little number in the corner is 0, because this is saying that the difference between, if you did the subtraction of x bar and mu, is 0. And again, this is a very simplistic way to talk about the null hypothesis, but one of the best ways that my students have kind of like gripped onto the null hypothesis is to just be a negative person. Just the person to say, no, nothing is happening. Nothing is different. Everything's fine. The given mu, the null hypothesis, is the person who's saying that there's nothing, crazy going on here. It's just, that's the average. Where the alternative is waving their hands frantically and saying, yes, there is a difference. So the alternative hypothesis is to say there is a statistically significant difference between this parameter that we're testing and the sample average. Because the sample average should not be wildly different than the average. Imagine that you're working at a casino and you're a tech person for all those beautiful slot machines, and you have this gut feeling that the slot machines are not working correctly. Now, the null hypothesis person is saying, there's nothing wrong with those machines, they're paying out fine. But you, being the smart math person that you are, start running the numbers on payouts, and you start to realize that, the payouts are statistically significantly different than what you think they are. And that's very important, because for a casino to be profitable and for it to be actually more profitable is they want their slot machines to pay out enough to keep people playing, but not too often to make them lose money. So that is the alternative hypothesis. So what this chart is going to help us do, it's going to help us get some ideas about how to recognize symbols for the null and the alternative. Now, 99% of the time, well, maybe that's a little high, maybe 90% of the time, your null hypothesis is just going to be is. That's saying the average is this. So the symbol you're going to use is an equal sign. Now, if your null hypothesis is the word is, and your alternative is to basically say is not, then the symbol is going to be not equal to. So this is an example. If we have, let's say, a car that's supposed to have a battery that works without any kind of recharging for 12 hours. So the mu is that 12, and the alternative, would be basically someone saying, I don't think the answer is 12. They're not specifying more or less than 12. They're just saying it's not 12, so not equal to. You could also use the phrase, and this is a very common phrase, is different than. And the is different than indicates the not equal to. Now, you also can have somebody say, well, if you think that is true, I might think it's more than that. And that would mean that my symbol would be greater than. And sometimes somebody says, well, I think this is the answer. And you say, well, I think it's less. So it would be less than that. So when you see the equal to symbol, that doesn't necessarily give you the clue as to what to do for your alternative. That you have to look at the problem. And I have some examples below. But what if the null hypothesis made a claim that something was greater than or equal to? So the symbol looks like this. The null hypothesis says, oh yeah, our workstations here can produce greater than or equal to 1,000 forms per hour. And then someone says, oh, I don't think that's true. Then they would have to be less than. Because they're making a contrary position to your null hypothesis. Because you want your machines to produce over 1,000 per hour, greater than or equal to, and they're saying like, nah, it's less than that. And the same thing goes here if the null hypothesis says, well, we're actually less. Let's say you're trying to keep something small here, like a failure rate. Our brake pads are less than or equal to a certain amount of failure. So we want to have a low failure percentage. So we are less than or equal to. If you're going to be contrary to that, then you're going to be, well, you're just going to be more than that. Okay? Just going to be more than. Now, the purpose of showing you this table is to kind of highlight opposites. The opposite of equal to is not equal to. And in some cases, greater than or less than, depending on the purpose. But the opposite of greater than or equal to is less than, and the opposite of less than or equal to is greater than. You'll notice that all the null hypotheses in each of these problems have an equal sign in them. Notice this is an equals, and that is an equals, and that is an equals. There are no equal signs over in the alternative hypotheses. First of all, it's a little bit of a philosophical discussion that continuous distributions will not land on a specific thing. But let's say this isn't continuous and it's discrete, then you can't have a piece of data or information in more than one camp. It's either going to be working for the null or the alternative. So make sure that your null always has an equal sign in it, and your alternative never has an equal sign in it. And if you're thinking, what about not equal to? It has an equal in it. Well, but it's not equal to, so it counts. It counts. Don't try to get me with that funky logic there. All right, now let's get to some examples to end this video. Example number 1. We want to test whether the average GPA of students in American colleges is different than 2.0 out of 4.0. So the word test means we're talking about the alternative. So this alternative, let's put a colon here, is going to be the average, and we want different than 2.0 out of 4.0. So this is basically saying the alternative is saying, I don't think the GPA of colleges is 2.0. I think it's different than that. Then the null would come along and say, oh, well, you know what? I think it's 2.0 all day, every day. So that's the contrary positions in this problem. Now, let's take a look at this second example. We want to test if college students take less than 5 years to graduate from college. This could also be your claim. You could say like, oh, I think college students finish in less than 5 years. So this test or claim, and you're going to see those words interchangeably here, we want to basically focus again on the alternative. The alternative here is basically stating that the average is less than 5. Okay, notice that there's no equal to symbol there. And then our null would basically be like, oh, no, it isn't. It's definitely greater than or equal to 5. So You could also, I mean, if your null could be equal to 5, again, I don't think you're going to see a lot of differences there, but a lot of times people like to play opposites off of the alternative. Okay, so this last problem before the end of this video deals with a percentage. Oh, interesting. Percentage. The percentage is not an average. Your percentage is actually going to be given a special letter. In this case, it's going to be given letter P for percentage, but also this is the percentage of success, and we're going to give it a little p sub 0 here. So this is testing if the percentage of United States students who took an advanced placement test is more than 6.6%. Ah, well, in this case, it's not a mu, it's a p sub 0. And that p sub 0 is going to be greater than, notice it said more than, all right, because that's what we're testing. And we're going to turn this into a decimal. Okay, so this is going to be 0.066, and this is 0.066, because that would be moving the decimal 2 spaces over. So that gives you our null and on our alternative. So you've just been introduced to the fact that if we're not testing an average, we're testing a percentage. And we're going to see this later on in videos to come in this section, because we now, in our next video, get to talk about errors.